nice to see you all here. I hope you are still excited about historical dive talks, because we already had a few of them. Can you raise a hand if you ever struggled with keyboard handling in a React Native? I see a lot of people. OK. My name is Kiryl. I'm a software engineer at Margella, and today I'm excited to take you on a journey through the keyboard management evolution in React Native. You can think of it as a space-time adventure. We will explore how keyboard handling has changed over time in a React Native, with a few cosmic metaphors to thrown in to keep things fun. So buckle up, we are ready for liftoff. The React Native framework was released in 2015, and early adopters quickly began experimenting with the new framework. However, they soon ran into a major pain point. There was no proper way to handle the on-screen keyboard. In version 0.11, the React Native team introduced a new component called Keyboard Avoiding Queue, designed to address that issue. And later on, the Android support has landed. But what exactly Keyboard Avoiding Queue is doing? The answer is quite straightforward. By default, iOS doesn't handle the keyboard, and instead it delegates all the responsibility to application developers. Looking at this markup, many React Native developers will say, just add keyboard avoiding queue, and everything will start work as expected. And they are totally right. When we wrap our layout inside keyboard avoiding view, our inner content is getting resized and pushed above the keyboard, so everything works as expected. But let's have a look how it works on Android. And in reality, on Android, the keyboard avoiding queue is not needed in most cases. The Android resizes view automatically, and the way how it's getting resized is controlled by window soft input mode setting. And Android typically doesn't animate these transitions. The layout just jumps into the place. And with info that we just learned, a reasonable question comes to mind. Did we master keyboard handling? The short answer is no, not yet. We are only at the beginning of our exploration. And let's take a look at cases where keyboard avoiding queue falls short and continue our journey. Many React Native developers immediately notice that keyboard avoiding queue doesn't handle large forms really well. And indeed, if you set focus to inputs that are very close to header, when keyboard is getting shown, the content can be pushed and your input can be obscured by header. It happens because keyboard avoiding queue doesn't know anything about focused input layout. It simply resizes the container, and because of such thing, it happens. Fortunately, in November 2015, a new package by community was released, which is called React Native Keyboard Aware Scroll View, which was designed to solve that problem. And to a large extent, it did. For sure, this package had some downsides, like animations are a little bit desynchronized. It didn't track inner layout events. So if you have multi-line text input and if your multi-line is growing, it wouldn't scroll into visible area. But this package was written entirely in JavaScript, and contributors from all around the world have contributed to that package to make it really stable. But how does it work on Android? On Android, again, this component is not needed because Android resizes view automatically. But we all know that React Native stands for native, right? And in fact, keyboard handling is not a React Native problem. It's a common, long-standing issue in iOS ecosystem. But since React Native relies on native libraries, the question is, do we have a solution for this on a native language? And the answer is yes. Many iOS developers are using IQ Keyboard Manager, and we have a corresponding wrapper, React Native Keyboard Manager. This package offers excellent, perfectly synchronized animations. It delivers the experience that iOS users expect to see. It can be easily integrated as a global module, and on top of everything, it's also bundled with additional UI features like a keyboard toolbar that can help you to simplify keyboard interactions by providing additional button navigations between text input, as well as done button for closing the keyboard, and overall it feels like a great input accessory addition. So at this point of time, it looks like we finally found the gold standard. We can use React Native Keyboard Manager with all its advanced features on iOS, and we can rely on default Android handling. And indeed, this combination was popular for years. But in fact, Apple do not stop here, and they continued to improve keyboard experience by introducing even more advanced capabilities. And one of such capability was an interactive keyboard dismissal. This technique is commonly used in many chat-like applications, and basically it allows you to dismiss keyboards as you scroll the scroll view, literally by gesture. To support this, React Native team introduced a new component, which is called Input Accessory View, which not only plays nicely with interactive keyboard dismissal, but also let your inner views to be sticky to the keyboard. Before we go to further slides, let's take a quick pause and see what we've discovered so far. So, by default, window is not resized on iOS. Instead, we get events when keyboard starts its movement and when it's finished. So we can apply animations and move nicely elements around the keyboard. iOS also has rich ecosystem. We have tools like IQ, Keyboard Manager, and these tools are bundled with additional features like Keyboard Toolbar, and on top of everything we have interactive dismissal. But what Android offers in terms of parity? Well, actually, Android handles everything for you, so you do not have to bother. But is full automation always a good thing, especially when it comes to customization? Let's take a look at a quick example at a simple layout. So here we have header, pretty large form, click to action button, and bottom tab bar. Effectively, when keyboard appears on the screen, we expect that our bottom tab bar will be rendered beneath the keyboard, and our button will be sticky to the keyboard and will be shown above the keyboard. And such layout is totally achievable on iOS because we have a control of each aspect of keyboard animation. But on Android, typically layout would look like this. It happens because window is simply resized and the content just pushed above the keyboard. And here is the big question. Can we fix it somehow? The answer is yes. React Native ecosystem kept evolving, and the next big milestone was the creation of a React Native Avoid Soft Input. This library aims to deliver a true cross-platform experience by enabling animated keyboard transition and disabling automatic window resizes on iOS, on Android, sorry. And this library made a major step forward in terms of controlled keyboard handling. It brought us closer to a smooth and consistent experience on both iOS and Android. However, on Android, animations are still desynchronized. So let's continue our journey even further and see if we have a solution to this problem. Let's quickly step into parallel Android metaverse to see what has been changing there. In 2020, Android team released Android 11 and a new API called Window Instance Animation. And this API marked a real breakthrough in controlled keyboard handling. For the first time, developers could smoothly animate UI elements with sync keyboard movement. And it was exactly this API that inspired creation of a React Native keyboard controller. Before building this library, I had few key design principles in my head. And yes, I'm the creator of keyboard controller. Nice to meet you. all. First and foremost, it had to work consistently on both platforms, delivering the same experience and behavior. Second, just as important, it should offer a unified API without a need to write a conditional code for each platform. And last but not least, it had to offer the same feature set parity on both operation systems. The first missing piece in React Native was the lack of keyboard will show and keyboard will hide events. And keyboard controller fills this gap by introducing a module which is called keyboard events. However, due to platform differences, we can easily utilize it on iOS, but on Android, if we will try to use it, we still will have desynchronized animation. It happens because on iOS, we have a single manufacturer, and animation curve is the same on all devices and on all operation systems. On Android, situation is a little bit different. We have different manufacturers, we have different OS versions, where each OS can customize the keyboard animation curve. To solve this problem, I introduced two new hooks. The first one is use keyboard animation, which basically returns you two values, height and progress, which are both animated values and are driven by native driver, which delivers exceptional performance. And finally, we can have a totally synchronized animation on Android. Thank you. However, built-in animated from a React Native had its own limitations. For example, you cannot animate width or padding or other layout properties. So I added a counterpart hook, which is called use reanimated keyboard animation, which basically does the same as use keyboard animation, but instead returns you shared values instead of animated values from a React Native. And this hook expands the range of use cases where you can use it. However, sometimes you need to have a fine-grained control of each frame during keyboard animation. And this is exactly where use keyboard handler comes into the play. Basically, this hook gives you 4 callbacks, which are invoked when keyboard is moving. How it works? It works pretty simple. Before the keyboard shows, we will receive onStart event, which will contain destination values. Then, as animation continues, the onMove handler will be constantly getting called, reporting current keyboard position on the screen. And in the end, when animation is completed, the onEnd handler is getting called. So you can write your imperative code directly inside worklets and perform animations on UI thread without any desynchronization and have an absolute control of each aspect of keyboard movement. And you can see that we also have onInteractive handler, and we already knew that we can dismiss keyboard interactively on iOS. But what about Android? Is it even possible to have something similar on Android? The answer is yes. Window Insets Animation API not only gives you the ability to read current keyboard frame, but it also gives you an ability to control keyboard position. Internally, interactive keyboard dismissal works totally different on Android and on iOS. And to unify the API, I introduced a new component called keyboard gesture area, which basically tells you where is the region of your gestures on the screen, which can control keyboard position. Typically, you wrap scroll view inside that component, and after that, you need to select an interpolator, how exactly keyboard position will be controlled by your gesture. And in reality, all of these hooks and keyboard gesture view, they work perfectly. But in most real-world scenarios, you just need to avoid the keyboard. And you, as a developer, typically you wouldn't like to write a lot of repetitive code. In general, if you find yourself repeating code again and again, it's a sign that something is off. And this is where React declarative approach shines. By leveraging these hooks internally, we can create high-level components which will help us to build flexible tools for keyboard avoiding. And first such thing is keyboard avoiding queue, already well known. Basically, this component works identically to what we have on a React Native side, with one key difference. Its implementation is totally rebuilt using keyboard controller API, and because of this, it works identically on both iOS and Android, offering you perfectly synchronized animations. And it's totally drop-in replacement for default keyboard avoiding queue, but a part of keeping the same interface. This component also extends behavior props with additional, such as translate with padding. On the other side, sometimes we don't need to resize our layout, and we just want our views to float around the keyboard. And in this case, keyboard sticky view really shines. That layout that was challenging before on Android, now you can see that it works as expected, with perfectly synchronized animations without UI glitches and other unpleasant things. It works similar to input accessory view, but you are also allowed to specify conditional padding for closed state and for open state, which is really nice because input accessory view has some limitations. I also rebuilt keyboard-aware scroll view with some additional improvements. The default implementation, as we saw in the beginning, had animation desynchronization and other issues, and the package from my keyboard controller solves this problem. The animations are perfectly synchronized and delivers the same performance as IQ, Keyboard Manager, but on top of everything, we also track additional events of focused input. So if your input is getting growing, the keyboard-aware scroll view takes care of it and will automatically scroll it into a visible position. And we also noticed in the beginning of presentation keyboard toolbar, and we also can rebuild it. We can utilize keyboard sticky view to make our toolbar be always above the keyboard. And we can utilize a pretty simple API called setFocus2, which basically gives you an ability to move focus from a currently focused input into a given direction, or restore focus if keyboard was already closed. And if we get back for a second to comparison, now we can see that Android and iOS achieves the same parity. Window is not automatically resized on Android. We also have animated transitions thanks to use keyboard animation hook. Rich ecosystem, well, Android doesn't have it, but it doesn't have to, because we can re-implement components such as toolbar ourselves, and we also have interactive keyboard dismissal. Did we cover everything? Well, not yet. Let's consider cases which are even challenging on native development. The first such thing is over keyboard view. Basically, it acts as a model with one simple difference. By default, it doesn't close the keyboard when it's shown, and it shows all its children over the keyboard. It has a variety of use cases. If you're building gallery-like applications, or if you have attachments in your chat-like applications, you can use it. You can use it if you want to show context menus like Telegram does. It looks just perfect. You can use it as overlay for your keyboard to show additional actions similar to what WhatsApp is doing. Or you even can use it as a container for your bottom sheet, which also looks quite good and delivers cool transitions. And in fact, we've considered all components that are designed to kind of avoid keyboard in one or the other way. But in reality, keyboard controller is not about avoiding keyboard. It's about controlling it and even extending it and its functionality. And I'm happy to reveal some upcoming features in keyboard controller that pushing boundaries of what's possible in a React Native. So the first component is called keyboard extender. Basically, it allows you to embed your custom views inside the keyboard and display them right above the keyboard. If you are building a payment UI, you can display a predefined amount of your currencies, and it will make your flow for users intuitive and more faster. Due to platform limitations, it cannot embed certain views like text input, and to overcome this problem, I'm introducing another component which is called keyboard background view. This is a very simple component with one purpose. It should perfectly match keyboard UI. And it can be used in kind of shared element transitions where one element morphs into another state. You can think of it as a canvas for your input accessory views. On a slide, you can see how we can rebuild Safari URL search animations using this component. But you can also build advanced interactions around the keyboard using this component. For example, you can create a component that emerges from the keyboard with meatball animation, and with just a bit of creativity, components like keyboard background view and keyboard sticky view let you go far beyond simple avoidance. You can build rich interactive UI that actually extends the keyboard. And instead of just avoiding the keyboard, you can design experiences that work with it, or even feel like they are part of that. Thank you. And we are landing. Let's make a brief summary of what we've learned so far. We've navigated through a decade of React Native keyboard handling evolution. Just like humanity turning early spacecraft into sleek shuttles, the React Native community turned awkward keyboard workarounds into elegant solutions. With today's tools, handling keyboard doesn't have to be a problem or developer's nightmare anymore. We can confidently say that we have a right tech to solve keyboard handling issues. Second point, do not be shy away from building advanced user experience around your keyboard. In the past, developers may afraid fancy animations fearing keyboard issues, but now, armed with tools like keyboard background view, keyboard extender, and other, you can build rich keyboard interactions. Using interactive keyboard dismissal, keyboard toolbar, keyboard avoiding queue, and other components can help you build fluid keyboard interactions, and your users will thank you for a smooth ride. And you, as a developer, can move on to solving bigger problems, because keyboard is no longer a black hole of despair, but instead a well-known part of your application galaxy. Happy coding, and may the keyboard force be with you. Thank you for your attention.